The government is committed to the task at hand. The scientists and employees of the Alikhanyan National Science Laboratory, formerly Yerevan Physics Institute, will already feel the tangible results of this commitment in 2011. The specific research directions which will become the focus of the National Laboratory have been already established. During this news episode, we will also report on the latest discoveries of our physics phenomena which is directly above our heads. Science deserves attention. These words are no longer the subject of mere speeches from podiums. The government support promises beneficial results in the sphere of Armenian scientific research. In June 2011, the Armenian government renamed the Yerevan Physics Institute with its 70 years old history as the National Science Laboratory, named after Artem Alikhanyan. The change of the institute name will first of all be accompanied by the injection of state funds into this branch of science and the strengthening of its most important research directions. As an initial step, the government has promised to double the budget of the former institute. The executive body has suggested to the National Assembly to budget 600 million drams for the National Laboratory instead of the previous year's 300 million drams. Starting next year, the laboratory will finance new research and scientific projects of Armenian scientists. It's more important in silence to find the right direction of work than to find money and funding. You can spend hundreds of millions of dollars and gain nothing from your work without proper direction. Conversely, with proper direction, you may build the best laboratories in small countries and make important discoveries with less funding as long as you take the right direction. The International Expert Advisory Group, consisting of high-profile physicists from around the world, has explored the potential of Yerevan Physics Institute and has recommended perspective directions for the institute most acceptable to meeting current needs. The government has approved the suggestions made by international team. This group of international experts demonstrated to us that we need to start a new direction to create our new modern accelerator center, which is concerned with solving modern issues in general. Particle accelerators used for practical applicants have about a $36 billion market worldwide. The Armenian history of particle accelerators is connected with the largest Soviet accelerator, ARUS, built at the Yerevan Physics Institute for high-energy physics research. The second breadth of accelerator technologies in our country will be used in the medical sphere. Already the most ambitious scientific idea of our independent country, the goal of creating a nuclear medicine center in Yerevan, is on its way to being realized. Unfortunately, with each passing day, cancer is being more and more spread. We need to have equipment that provides the short-lived isotopes that are used in the diagnosis and treatment of cancer. We have taken the production of such isotopes on ourselves and are already making progress in that direction. An 18 million electron-volt proton cyclotron worth 5 million euros is being constructed in Belgium for Armenia. In 2 years, the nuclear medicine center on the territory of the National Laboratory will be a reality and will begin production of medical isotopes for nearby hospitals. And finally, the National Scientific Laboratory plans to become a registry of scientific data in cosmic ray physics, gathering published results of various experiments and making it available to the world via internet. If we gather the results of all experiments in one place and combine the wealth of data with the wealth of worldwide expertise to develop extensive analysis techniques and share all this with everyone via internet, then we will be able to discover new science and expand our knowledge. During the last years, it has been found that additional particle fluxes are formed in clouds during thunderstorms. We have registered these particles with our detectors at our research stations. The radiation from these particles is comparable to X-ray radiation. For example, when the planes in flight approach thunderclouds, the crew and passengers in them are exposed to radiation similar to X-ray radiation. Elementary particle acceleration in Thunderous clouds. This is the new field of study at Aragat's research station at 3,200-meter altitude on Mount Aragat. The reports presented by the Armenian and international physics in the past 5 days during the international conference at Nuremberg Research Station are precisely about this subject. Here we met a completely new physics. We use the term new physics when something is outside the known rules of physics or something cannot be explained by the existing rules of physics. We do not yet know what physical laws should be used to explain these physical phenomena. Thus, 40 physics from Russia, Germany, United States, Great Britain and Armenia participated in the International Scientific Conference on Thunderstorms and Elementary Particle Acceleration at Nuremberg on Mount Ararat. The Armenian scientists have made these unique discoveries at the research station located on Mount Ararat. This is a very interesting topic, and we are recently discovering that it is not only in the solar system and the far reaches of the universe where elementary particles are accelerated, but electrons are accelerated in thunderclouds up to 50 million electron-volt energy, which is rather high. This energy is equivalent to the energy of the particles created in the atomic bomb explosion. Since this high-energy phenomenon is very close to us, just above our heads, it's of great importance both for fundamental physics and its practical effects. During the last 1.5 years, Armenian physics have made new discoveries of international importance. They have already separated two types of particle acceleration methods in thunderstorms. NASA physics, who have made similar measurements on the satellites in space, are interested in the results of the physics from this small country who have made ground-based measurements on the same phenomena in the upper layers of the atmosphere. For the first time ever, using our detectors on Mount Ararat, we have recorded gamma ray and electron large fluxes correlated with thunderstorm activities. We have not only detected the existence of this phenomena, but we have also measured the particle energy spectra, which no one else has done before us. Our discovery of neutron fluxes from the thunderclouds is also a very important solution of a long-standing physical problem of their origin. The group of scientists at the Cosmic Ray Division of Yerevan Physics Institute is well known in the international arena. They are known in different areas of cosmic ray research, especially in this new field of measuring these new types of radiation in the atmosphere. They are in the leading position of the world, meaning all the laboratories of the world that do similar research in the sphere knew well that there is a group in Armenia that leads in this very interesting and productive research. This is the fourth day of scientific conference. Instead of the conference room at the Nuremberg Research Station, now the settings of the scientific conference is moving higher on Mount Ararat. This is a special day. The guest physicists are climbing to visit the research station at 3,200-meter elevation on Mount Ararat. They will get acquainted with the Armenian methods and technologies of exploring cosmic rays. But before starting on the main mission, first of all, international guests are fascinated by the mountainous landscape. Here you can look as far as you can. The nature has depth, the landscape is endless, there is nothing in the way out for sight. There are no huge buildings obstructing the view. I feel I will lose my breath from what I see now. The station is close to the clouds and lightning, their frequency is very high here, so the conditions for researchers are just what they need. Arnold Wolfendale, who represents Durham University of the United Kingdom, has came to Armenia to share with colleagues the results of his research associated cosmic ray acceleration and the correlation of cosmic ray particles with global warming. He says that in Armenia, rather than impressing his colleagues, he himself was impressed and pleasantly surprised. I would compare the level of Armenian scientists to the highest levels of their colleagues from much more developed countries. What impresses me is that your physicists are so clever and quick-witted that they have managed to adapt old equipment to the new ones and are making important discoveries and research with it. This is truly an amazing achievement. Despite the natural low atmospheric pressure at the high altitude of Ararat Research Station, the 80-year-old scientist feels himself very well among the beauty of the nature. It is worth to draw attention to the fact that a small country like Armenia is able to make groundbreaking discoveries in fundamental physics. The discoveries associated with lightning are a very good example of that. It's impressive that phenomena associated with lightning have been registered not only on the Earth but also in space. Exactly 50 years ago, in 1917, I came to Yerevan and visited this station. It was April. There was a lot of snow. We somehow managed to reach the station. The well-known Russian physicist is not able to find many similarities between the Aragat station from 50 years ago and now. Instead of few huts, now there is a big research station with buildings, where space and sky are literally in the palm of your hand. Well, why have we all gathered here? Here in Armenia, there is a research station of international importance, where many characteristics of cosmic rays are studied. Petruchin says that the one circumstance that makes him happiest about this conference is his observation that Armenian science is getting a fresh breath. I listened to some Armenian presentations. I was especially pleased that young people who were working on their PhD degree delivered many of them. The Russian physicists are familiar with Armenian technologies of exploring cosmic rays since a long time ago. Research groups of two countries have worked together for years. Petruchin has now come to Armenia to suggest a new cooperation between Armenian and Russian physics. In Moscow Physics Research Institute, we have made a muon detector which does not exist here. We are interested to have Armenian technologies in our institute, and Armenian scientists want to have our technology here. The discoveries that the Armenian scientists are making at the Mount Aragat research station, others are making with equipment located on scientific satellites in space. Our scientists are the first in the world to detect elementary particle acceleration in thunderstorms, a phenomenon which, according to the physics, may have an effect on global warming. This research is very valuable on the international scale. We highly appreciate the research results achieved by our Armenian colleagues from Yerevan Physics Institute. Now we have another mission: how to quickly publicize these results to the international physics community. Now it's time for publication and presentations at conferences. That is what we are doing now here. Famous physicists around the world have gathered here, thus I'm sure that the whole world will learn about this research very soon. The international scientific gathering served its purpose: the first exchange of information about the study of elementary particle acceleration in thunderstorms, and gaining the attention of the international scientists on this new phenomenon was successful. In addition to its primary scientific purpose, this conference provides something else: that science has no boundaries. The country's size, power, and economic standing are not the only definitive factors of making great discoveries. Time will tell how much the discovery of Armenian physicists about the energetic processes right above our head will attract the attention of the international scientific community.